Hey guys, this is the Unit 8 Work in Simple Machines first lesson. Today we'll be discussing work. The definition of work is a transfer of energy that occurs when a force makes an object move. It is measured in joules. The formula is work equals force times distance, or W equals F times D. If you would like to use the triangle to help you with your math, make sure you put the W on top and F and D on the bottom. I remember this because I grew up in Whitesboro, and I like to remember it as Whitesboro Fire Department, and Fire Department's on the bottom. Remember, whenever you're using the triangle, to cover up what you're looking for or what the problem asks you for, and then you are left with the other two letters. If they're on top of each other, you divide. If they are side by side, you multiply. A joule is the unit of work. It is important to note that 1 joule is the same thing as a Newton meter. Work is force times distance, and force is measured in newtons, and distance is measured in meters. So a joule is the same thing as a Newton meter. There are 2 requirements for work to be done. The object that the force is acting upon must be moving, and the person must be making it move by applying a force. If there is no movement, there is no work. For example, if I was pushing really hard against my wall, and I was grunting and pushing and trying to knock it over, and it didn't budge, even though I was exerting a force, there would be no movement, so there is no work. If all the forces are balanced on something, and there is no movement, so there is no work. Imagine you have something sitting on your desk. Gravity is pushing it down, but the force of your desk is pushing it back up. Since the forces are balanced on it, it's not moving in any direction whatsoever. Since there is no movement, there is no work. For work to be done, the direction of the applied force must be in the same direction of motion. For example, if I was pushing against the front of a moving car, and the car kept moving towards me, even though I was pushing it away from me, I wouldn't be doing any work on the car. In fact, the car would probably be doing work on me and pushing me the direction it was going. If Miss Weems lifts a 1250 Newton barbell 2 meters, how much work did she actually do? For this one, I'd like you to try to set it up. Put your formula, plug in your work, write your answer with the correct units. Pause this now and take a chance to work on this problem on your own. Here's what you should have gotten. You should have written the formula work equals force times distance. When you plugged it in, you would have noted that the force I exerted on the barbell was 1250 newtons, and I moved it 2 meters. So when I multiply those two numbers together, I get a total work of 2,500 joules. Joules is the unit of work. I could have also written Nm for Newton meter in the place of the J. Let's try another one. If Miss Weems weighs 700 newtons, which I don't, it's just a made-up number, and does 1,400 joules of work climbing a ladder, how tall is the ladder? Think back to your triangle. What are we solving for? We know force and we know work. We're actually looking for distance. Okay? So pause this one, try to set up the formula, plug it in, and find how tall the ladder is. Here's what you should have gotten. Distance equals work divided by force was your formula. Distance equals 1,400 joules, that's how much work I did, and divide it by how much force I have, which is 700 newtons. 1,400 divided by 700 equals a distance of 2 meters. So the ladder is only 2 meters tall. That's all for work. Thank you very much for paying attention.